Hello, I'm Dr. Hassan Tawheed, and I am back again with an amazing topic as usual. What is meta analysis? Yes, we will discuss that. And this video is for absolute beginners. If you have no idea what meta analysis is all about, then this video will serve as a benchmark for your basic concept of meta analysis. So let's begin. What is a meta-analysis? In order to understand what meta-analysis is, we need to understand different kinds of study designs, especially the review articles. So what are the review articles? Review articles are, in easy words, I'm talking to a person who has no idea about research so that everyone can understand. Even a 10-year-old kid can understand if he's watching this video. So let's begin. Review article. What is a review article? You need to understand what a review article is. Review article is a combination of so many papers together. When you combine so many papers together, you write one paper, and that is a review article. Let's say you are writing a paper on the side effects of smoking, for example. So what you will do is you will see one article related to smoking, bad effects of smoking. You will see another article published last year. You will see another article published 3 years ago. You will look at another article, and you will keep looking at different papers, and you, let's say, find like 50 or 60 or maybe 100 different top papers, different articles written by different people, and they could be different designs. Some could be clinical trials, some could be observational studies, some could be just review articles, and you have a combination of so many papers together. Now, when you have these papers together, you combine the information written in those papers and you write one paper out of that information. So yes, actually combine the information written in those papers and you write one paper out of it. So this is how you write a review article. Now, review article can be of different kinds. Traditional review, or simply known as traditional review, that is simply known as literature review. Now, the second one is the scoping review. Another one is a mapping review, and systematic review, and meta-analysis. So now let's talk about the most common kinds of review articles: traditional review or literature review. So what is a traditional review, also known as literature review? When you combine information from previously published papers, let's say you saw 10 papers related to a topic, let's say squamous cell carcinoma of XYZ. You saw 10 papers, now you will write one paper combining the information from those 10 papers. That's a traditional review or literature review. How do you write it? You just write it like an essay. It's a broad topic, you write it like an essay. You don't follow any guidelines usually, and you just follow it and you complete your paper. That's it. Now, systematic review is the second most common in the review articles, and it's a way ahead. It's a step ahead of traditional review. So it's a kind of complicated, little complicated. Systematic review is a little complicated than a traditional review. So systematic review is when you write paper, same review article, in a systematic way. But here you don't have a broad topic, you have a narrow topic because you are answering a research question. So yes, you're answering research question and you follow certain guidelines like PRISMA, preferred reporting items for systematic reviews and meta-analysis. So you follow PRISMA guidelines to write a systematic review, and you check the quality of the articles that you have included at the end to make sure that the quality of the articles are really well. Because in the literature review, the normal traditional review, you don't check the quality of the articles. You include all sorts of articles, so the quality of the evidence can be good or bad, sometimes average, you don't know. But in systematic review, your aim is to make sure that you write the highest quality of evidence, and the strength of evidence is really, really strong. So that's why you check the quality. So you have a research question in systematic review, you follow PRISMA guidelines, you also have a strict inclusion-exclusion criteria, yes, and then you check the quality, and this is your systematic review. Then you write a systematic review. And the purpose of systematic review is to make a systematic review, a review that is so systematic that anyone who follows the method that is given by you, or everything that you did in your paper, If anyone repeats it, he or she will get the exact same result. This is what systematic review is, and that's why we call it a systematic review, because it's a system. Now coming to the most important one, the main topic of today, meta-analysis. So meta-analysis is also a review article. Yes, and the most advanced kind of review articles in simple words. So yes, don't get scared of the word meta-analysis. Remember, meta-analysis is also a review article. Just like traditional review, just like systematic review, meta-analysis is a review article. In fact, let me make things easier for you. Systematic reviews become meta-analysis. Let me repeat that again. Systematic reviews become meta-analysis. Yes, you convert your systematic review into meta-analysis. Now, how do you convert systematic reviews into meta-analysis? Remember, every meta-analysis is a systematic review actually. You first do a systematic review and then you see if it will become a meta-analysis or if it will remain a systematic review. That's it. That's why all meta-analysis papers are actually systematic reviews, but not all systematic reviews are meta-analysis. For example, like every master's student is a master's student, right? But not everyone goes on to do PhD. Same thing, systematic review, let's say master's student. Not every master's student goes and does PhD. Same thing with systematic review becomes a meta-analysis. So every systematic review is not a meta-analysis, but every meta-analysis is actually a systematic review. Just like every PhD student has to do master's first, right? So you can relate it now to understand this, that systematic reviews will become meta-analysis, but not all systematic reviews will become meta-analysis. Now, let's say you have done your systematic review. Now, you have collected your data. Now it's a step to decide whether it will become a systematic review or it will become a meta-analysis. Now, how do we decide it? Meta-analysis is actually also a combination of so many papers, but similar papers. Yes, so you need to see if your data is homogeneous or heterogeneous. If the studies are heterogeneous and they're really, really different, then it will remain like a systematic review and you will do the narrative summary of that paper. But if the studies are homogeneous or they are somewhat homogeneous, that means they are a little bit heterogeneous, they are a little bit different, but not too different, then yes, they can become meta-analysis, highly likely. In fact, they will become meta-analysis. You will apply the statistical rule and you will make it a meta-analysis. So now we understand how systematic review can become meta-analysis. Now coming back to the definition, what is a meta-analysis? What is the meta-analysis? Meta-analysis is actually a statistical systematic review in easy language. Remember, I'm talking to beginners. If you are an already accomplished professor, you have written systematic reviews and meta-analysis, I know you would say what kind of definition he is saying. I'm talking to the beginners here. So it will help them, and possibly it will help many of you as well, even if you have written papers before. So systematic reviews become meta-analysis, we know this, and meta-analysis is a statistical systematic review. It's a statistical review. Quantitative, in statistical analysis or statistical paper, we mean like quantitative paper. That means the numbers are involved. So if your paper has so many numbers involved that now you have to use statistical data analysis software to analyze your data, then this systematic review will become a meta-analysis. Yes, so remember, a systematic review where you need to use software to analyze data, that review article is known as meta-analysis. And the studies should be homogeneous or little bit homogeneous to make sure that it is a meta-analysis. So this is what meta-analysis is all about. So what is the definition of meta-analysis? Pooling of results. Pooling of results of different studies is meta-analysis. So now a little bit difference. In an ordinary systematic review that is narrative, we combine different kinds of papers. They can be totally different. And then we write a narrative summary, right? But in systematic review, in which the studies are quite similar or they are somewhat similar, now this means these are homogeneous studies. So you will use statistical data analysis software to analyze and calculate the results. So pooling of results is meta-analysis. What does that mean? It means that, for example, in one paper, let's say you have 10 patients. Second paper, you have 15 patients. Third paper, you have 20 patients, and XYZ. You will just count the total number of patients. So pooling the results. So now you're pooling the results. That's why you need statistical data analysis software. Now you are looking at the numbers. You combine the power of all the studies and you come up with a very powerful paper. So meta-analysis is statistical pooling of the results of previous studies. And then you explain what your findings actually mean. And you cannot do that without a software. So what kind of softwares are needed? Most commonly used ones. Number one is the review manager, RAVMan. We call it review manager or RAVMan, same thing. It is a data analysis software. The second most common one is R language, the R software. The third most common one is Stata software. So you can use any of those, whatever you are comfortable with. You can use any of those. So remember, meta-analysis is pooling of the results of the studies, previous studies, and you come up with a combined effect of the intervention. Yes, so what do you do in meta-analysis? You look at the effects of the intervention that you are studying. Remember, you had a research question, right? You had a PICO research question, just like you had in systematic review. P for population, I for intervention, C for comparison and or control group, and O for outcome, right? So you have these components, and this is a system. This is a meta-analysis. Now, this is a meta-analysis. Now you have a research question, you have an intervention, right? So this intervention you're studying, it will be discussed in all the papers you have collected, right? So you are looking at the effect of this intervention, collective effect. So you see paper number 1, you see paper number 2, you calculate the effect size. You calculate the effect size of study 2, study 3, study 4, and then in the end, you do a cumulative, a combined effect size of all studies. This is what meta-analysis is all about. Now you have done it, but remember, there are other things in meta-analysis you need to do as well. You need to draw a forest plot, and forest plot is drawn to see if the studies are homogeneous or heterogeneous. So it will help you. It will help you further. So that's why forest plot is very important. And the next one is the funnel plot. We'll talk about that. But now effect size is created, right? But the next step is always to decide, how do I do my meta-analysis? Because there are two methods, two most common methods. Which ones? Fixed effects model and random effects model. Fixed effects model and random effects model. So you use any of those methods. Remember, both can give you the same results, but not always. That's why the experts recommend that always go with the random effects model, because some studies have shown that if you do the same data analysis with fixed effect and random effect, you do get the results. Most of the time, the results are same, but sometimes it could be different. That's why random is preferred, because random assumes that the studies have heterogeneity, and the fixed effect model assumes that they are homogeneous. Or you can say another way of explaining this is that, let's say there's a true effect in all the studies. The effect is there's a true effect of the intervention. So that's the fixed effect model. That's what it assumes. But it is not always possible. It is impossible, I would say. Like, for example, one medication can give some effects to people in the US, but the same medication may not give the same effects to people in Japan. The same medication cannot give the same effects to the people in China. So the same medication can have different effects. It's not possible that the same medication will have the same effects on everyone. So that's why fixed effects model can have an error. Random effects model assumes that the drug or the intervention can have different effects on different people. So I'm talking to laymen who have no idea about meta-analysis. Remember that. So I'm deliberately not using the scientific terminologies. I'm teaching you from the very basic, from the very beginning, so you understand what exactly it is. So now, fixed effects model, random effects model. Fixed assumes that there is an effect, and that there is a true effect, and everyone will have the same effect, which is not actually true all the time, most of the time. That's why random will assume that there are differences. So that's why random is preferred. So you choose random effects model most of the time. So go with random. That's what I would suggest. And then, of course, then you draw the forest plot for heterogeneity. You will also look at the weight of each study. And we will talk about forest plot in the future as well. And also then you move to the publication bias. You look at the publication bias, and that is seen by funnel plot. You do the funnel plot. Once that is drawn, you have the funnel plot done. You now know if there was a publication bias or not. Publication bias means that some journals just publish studies that have positive findings. So a lot of journals are missing the information that could be actually very, very relevant. That's why in writing a systematic review and meta-analysis, we always include gray literature, unpublished papers, those papers that were rejected by journals. And there are ways to find it. You can find it through different ways, different sources. Just Google it right now, how to find gray literature. I'll discuss that later as well. Now, once that is done, then you do the sensitivity analysis. Sensitivity analysis means that if you remove one study, will there be any difference? So once that is done, your meta-analysis is ready. And once the meta-analysis is ready, now the process of writing begins, and you write your meta-analysis. So this is what a meta-analysis is all about. It's a statistical pooling of results in which you choose between the two models, fixed effects model, random effects model, most of the time random effects model, and then of course you are calculating the effect size. You calculate the effect size of each study, and you see a cumulative effect size, and then you draw the forest plot, and then you draw the funnel plot, and then the last thing is a sensitivity analysis. So this is what a meta-analysis is. And why do we do it? To get the strongest evidence, to increase the strength of evidence, to increase the precision, to increase the power of the results of the study. That's why we do meta-analysis. And who will do meta-analysis? You will do it with your team. Why do you do it? To get the best evidence, to increase the power of the results. And where do you do it? You can do it anywhere. You can do it right now, sitting home. You can start, make a team, and you can do it because the data is available everywhere in different databases. And when do you do it? You can start right now. Stay tuned, and we'll meet again. Thank you.